stuff too. So there'll be some old stuff thrown in here, but we're not frightened of that. You can do it. All right, so let's look at number 1. Oh, this is so easy. We're going to figure out if it's arithmetic or geometric, and we're going to find the common difference or ratio. Okay, so tell me what you think about A. What do you think about it? Jacob, you paying attention?
No.
I didn't think so. Thank you for being honest. Let's focus now. What do you think about A? Anyone? Arithmetic, yeah. It's arithmetic when it's a noun, it's arithmetic when it's an adjective, but I don't care. It's arithmetic, and the difference is -4. Make sure you say -4, right? Because what would happen if it were 4? The terms would be going up, right? Okay. B. Arithmetic with a common difference of 2/3. You can add fractions just like you can multiply them, guys. That's adding 2/3. Okay, what about C? That's neither one. You aren't responsible for figuring out the pattern. You might be able to, but you're not responsible for that. All you gotta do is figure out, am I adding the same number or am I timesing by the same number? Neither one, so that's a neither. What about D? Geometric, and the ratio is? 1/2. We're multiplying by 1/2. E, now E is written differently. There are a couple, who's got an idea? I want to hear your ideas about E. What are you thinking about? Okay, we could plug in 1. We could find C sub 1. C sub 1 would be what? 3/2? And we could then, obviously, we want to plug in 2, the next number. So that would give me 1. And then I'll go ahead and plug in 3. 3 would give me 1/2. Now, that's really enough, because if it's arithmetic, we will add the same thing. If it's geometric, we will times by the same thing. What do you think? -1/2, adding -1/2, which means it is arithmetic. Anybody have a different idea? This is fine. This is perfect. I was thinking maybe somebody would rewrite this like this. Is that okay? And that is like y equals mx plus b, that form right there, which is a line, and we know the slope of the line is the common difference, it's the rate of change. So you could have figured out it was arithmetic from the actual equation itself. Okay, what about F? I got tricky on this one. Only because it's only tricky because of this exponent right here. So it sure looks geometric, doesn't it? And I think it is geometric. Let's work it out and see. What would the first term be? If I put in a 1, what would I get? 2? Because you're squaring this, that would be 1/4 times 8 is 2. All right, what if I put in a 2? Careful. You put in a 2, you're going to get this, right? And what does that equal? 1/2? Isn't that 1/2? And then if I put in a 3, that would be 8 times 1/2 to the 6th, which is 1/8. Thank you, Patrick. It sure looks geometric. Is it geometric? Yeah, it's being multiplied by 1/4. So what made this tricky was, think of your your geometric formula. Isn't it something to a power? This is a geometric looking thing. Normally, this number right here is your ratio. But because I stuck that 2 in there, the ratio isn't 2. Think of an exponential. Y equals a times b to the x. This is your ratio right here. But because I stuck that 2 in there, my ratio is actually -1/2 squared, which is 1/4. See that? Okay, good. All right, a sub n is arithmetic. Find a sub n and a sub 37. We've done a lot of these, it feels like. So tell me what you are thinking. It is arithmetic. They're telling us it's arithmetic. So what are you thinking? Julia, are you okay? Well, you're fanning yourself, and I think it's chilly in here. I don't care. That's fine. Fan away. I just think it's a little chilly in here. No one in this room has an idea. Thank you, Kennedy.
So, chemistry, Kennedy?
Subtract 17 by 7, and then divide that by 5.
So what you're saying is the change here, the difference here is 10.
Yes, divided by
And
5.
the difference here is 5.
Divide
Rate
10 by 5.
of change. So that each step is going to be 2. So the common difference is 2. This is arithmetic, so it's linear. Okay, so then what, Kennedy?
And then subtract 7 by 4 because you're going back.
Exactly, you're going back to. So Kennedy says if this is my sequence, there's the third term. I add 2 to go this way, so I'm going to back up 2.
Yeah.
So my first term must be 3. So a sub n is going to equal 3 plus 2 times n minus 1.
Yeah.
We'll clean that up. We agreed the other day we're going to do that. So a sub n equals 2n plus 1. And you can always check your formula. If you put in 3, you better get 7. So if we put in 3, do we get 7? All right. How about B? B says the fourth term is -1, and the difference is -2/3. Backwards, but in working backwards, we won't be subtracting 2/3, we will be adding it. So this is -3/3, so -1/3, 1/3, and 1. Is that right? Keep an eye on my arithmetic. I think that's right.
Yeah.
So a sub n is going to be 1 minus 2/3 times n minus 1. How does 5/3 minus 2/3 n sound? Wonderful. Well, I can check it easy enough. My fourth term is supposed to be -1. If I put a 4 in there, 5 minus 8, -1. Okay. All right, now we got a picture. Even if I didn't tell you in the directions it was arithmetic, would you know the picture in C was arithmetic? Because it's a line. Mm-hmm. So I need to know the nth term. Some of those points are kind of hard to see. So I'm going to, let's see. It looks like the second term is 1, 2, 3, 4. Oh, help me, my eyes aren't very good. Is the second term 1, 2, 3, 4, 5? Thank you. And then what's another one I can tell? The sixth term you say is -1?
Yeah.
All right, we can go with that. So can we figure this out the same way we did this earlier one? So it looks like what's happening here.
They're subtracting by 2.
Well, it's gonna be -6,
Yeah.
and this is 4. So my difference is gonna be -6/4 or -3/2. What's my first term? Be careful. What's my first term?
6.
1, 2, 3, 4, 5, 6, 7, 8. I don't think it's 6. 6 and a half. Okay. So 13 halves. 13 halves. Minus 3 halves in. Minus 3 halves. So let's clean that up. Did you get 8 minus 3 halves in? And then I forgot to find the 37th term before, but I'll do it now. The 37th term is whatever that is. -47 and a half.
I thought you did A1 instead of A0.
Well, now wait, when I wrote my formula, I did do A1. This is my formula. When I cleaned it all up though, yeah, because it's 13 halves plus 3 halves. All right, you and your partner now, would you do exactly the same thing for number 3? The only difference is, it is geometric. Okay, Kyle, you want to sit up for me, honey? Thank you. Is that how you lounge on the sidelines during a football game? No. Okay. We're getting ready for game day in here. All right, good, good. So right now, all of you, 3, A, B, and C, figure them out with each other. All right, 3, A, B, and C, here we go. Go ahead, get started, figure it out. Logic it out with your teammates.
I mean, we're looking at the ratio. No idea. for that and then just
Definitely do double check.
Let's throw in free throw 12. Make sure you have that parentheses.
We're done.
I think it's 1, 2, 8.
Yeah, six hours.
That's some integrity over there.
Something about that is on.
So this is one. Each issue would be. Yeah. There's no correlation. So that's the G's.
Stop that.
So I think it's just -1 because it goes the first place down to -3 and it's not
That's right, yeah.
Minus 2 equals squared. Really squared and then subtract.
Okay. This is it.
So basically it's going. But before we thought it was going to her, when it's really just going to the exact.
Yeah, because the negative messes up. Otherwise it would.
So.
Yep.
Or is it -1/3? A little one divided each side.
Oscar, are you sitting there? You done?
Well, it's because it's going down.
Okay.
Oh, I didn't do the graph.
Then don't sit there. Listen, that quarterback's gonna be running by you all night tonight if you don't wake up. Wake up. All right, here we go. Everybody okay with 1? We good on that? I got that for my formula, and then I got this for the 12th term. You okay? This is the second one. I kind of showed everything that was running through my mind. You certainly don't need to show everything that's running through your mind, but I ended up with this answer for the 12th term. Is that where you ended up? then this one, I looked at my graph, and the first point was 9, and the second point was -3, and the third point was 1. So I figured that my ratio was -1/3. Is that right? So then my formula became 9, which was the first term, times -1/3 to the n minus first. And then my 12th term, I'm not sure why the 12th's up there. The 12th term was this to the 11th power, but when I typed that on my calculator, I got a decimal, and when I tried to frac it, it stayed a decimal. So I thought, so I'm multiplying 9/1 times -1/3 to the 11th. That's the multiplication I'm doing. And since 9 is 3 squared, I went ahead and wrote it as 3 squared over 3 to the 11th. And that gave me -1 over 3 to the 9th, which I could then type into my calculator and get a fraction. Now that was some extra work, but that's how you could do it. If you wanted an exact answer, that's how you could do it. Okay, all right, here we go, number 4. Got these things for each table. Determine if the function is linear, exponential, quadratic, or none. Explain your answer. All right, so here you go. What are you thinking about when you look at the first chart? First of all, Luke, have you examined the x's?
Not yet.
Okay, well, let's do that. Let's examine the x's, and we see that they are going up by the same amount. We call those equal width intervals. Perfect. So now I look at my y's. What's happening to the y's? Going up by 1, and then 2, and then 3, and then 4. So tell me what I've got. Quadratic. How do I know it's a quadratic? It's increasing linearly. Oh my gosh, okay.
Locked in.
There we go, locked in. So in other words, it's increasing by the same amount. So if they were all 1s, 1, 1, 1, 1, 1, 1, then it would be linear. If they were 1, 2, 4, 8, then it would be exponential. But because it's what it is, it's quadratic. Okay, what about the second one?
Exponential.
Let's see, the first one. So the first one's going up by what? 3 halves? Is that right? 1/2 to 2? Yeah, 3 halves. And then the second one's going up by 6. And then the next one's going up by, what is that, 24? And I don't know what the last one is. But aren't I timesing by 4 each time? So another multiple of 4. So that one is geometric. These numbers are proportional. So it's exponential. Of my choices, it's exponential. All right, immediately following the exam, memes are very sure online, the number of people who have seen the meme. All right, so hour 1 is 1 hour after the exam. So this is after the first hour. We have, oh, I don't know how many after, but after the third hour, I have 2,500. And after the 6th hour, I have 2,000. 20,000. Using this model, how many will have seen by hour 10? Okay. What do you think? Anybody have an idea?
20,000 minus 2,500 divided
I gotta be careful with that, Kennedy, this is geometric. So I'm not looking at, if you think about it, here's your first, second, and your third term, and fourth, fifth, and sixth term. But you aren't looking for the difference here, you're looking for what do I have to multiply by times this to get to that? Xander?
You subtract them and then divide them.
Guys, it's geometric. Yeah, so I divide them, yeah. So what do I get when I divide here?
Around
8. So to get from this number to this number, I am timesing by 8. But I need to do that in 1, 2, 3 steps. So I need to multiply by R 3 times to make times 8. So obviously R is 2. Okay, now if R is 2, then this term right here is 1250. And this term right here is 625. So a formula for this sequence could be, I'm not saying it's the only one, but could it be that? And I want to know the 10th term, so I'll just put 9 right here. And that will be something big. Did you get 320,000? People, good job. All right, write limit statements to describe the end behavior. Okay, you can do this. Do it. Limit, make sure you're using correct notation. Limit, x approaches negative infinity. And limit, x approaches positive infinity. So this is your left and this is your right. Okay, what did you get left on the left side for problem A? On the left side, you're heading toward 0 from the bottom. On the right side, you're heading toward negative infinity. All good? Not much opportunity for partial credit on these, so make sure you're following what's going on. Okay, how about B? On the left side, we're heading to infinity, and on the right side, 0 from the top. Now, the next two were given to you as equations. So let's think about this for a second. First of all, this guy right here is critical. He is less than 1, which means this is exponential decay. So he's coming down like this. But look what we stuck out here in front of it. What does that do to it? That flips it upside down, which means it's going to look like this. Just take it and flip it over. So the limit on the left will be negative infinity, and the limit on the right will be 0 from the bottom. Good? Then on this one I got trickier too, because see that? Oh no, he can't be negative. So what does that negative exponent do to this guy? Turns him over, or makes it 1/4. So this is really 1/5 times 4 to the x, which means it's exponential growth.
Wait, what?
Oh, 1/4, oh geez. Flips it over, 1/4, which means it's exponential decay. This 1/5 changes the curvature, but it doesn't change the shape of it at all, okay? So this is gonna be the shape of that picture, which means on the left, it is positive infinity, on the right, 0 from the top. Got it? All right, here we go. Now, do it backwards. Sketch it from the information. What's it gonna look like if we're heading towards 0 out that way, and we're heading toward infinity out that way? Like that? Is that okay? And then what about the next one that says we're heading to negative infinity on that end and 0 on that end? Will that be this? And then C, as the input values for f of x increase without bound, the outputs get close to 0. As the inputs decrease, the outputs increase without bound. All right? As the inputs increase without bound, doesn't that mean as we go this way? As we go that way, the outputs are getting close to, no, x is going to infinity, but the outputs are getting close to 0. And as the outputs decrease, as the inputs decrease, the outputs increase without bound. Isn't that it right there? One more. The initial value is 6. Where do I plot that? The initial value is 6. Y-intercept. Perfect. There it is, right there at 6. And the function represents exponential decay. Number 8. The number of meals served in the dining hall has been increasing steadily each week. There were 254 meals served in the 3rd week and 458 served in the 15th week. So A sub 3 is 254 and A sub 15 is 458. And I'm going to eventually find out A sub 36. Arithmetic, perfect, love it. He says it's a steady growth, so that means a constant growth, so that's gonna be arithmetic. So now, Kennedy, we can use your favorite method here.
Yeah.
So we're gonna figure out what this difference is. What is that, 204? And we'll figure out this one over here, and that is 12. Does 12 go into 204? 17? So what is the 17? That's my common difference. So now I know D is 17. That's only the 3rd term, so can I just count back a couple to get my 1st term? So what is that, 220? That would be, is that right? So my formula is going to be 220 plus 17 times n minus 1, or 17n plus plus 203, keep an eye on that arithmetic. So in week 36, I got 815. So 815 meals will be is that right? 17 times 36, yeah. I did this already. Okay, now we've got a review problem. Now we have a review problem, so here we go. What are we gonna do? Guys, gotta stay focused, we're trying to get through this. What happens? What do I need to do? No, we're not gonna pull out our calculator. What are we gonna do? Factor, won't be 3. 6 and 1. And what about the bottom?
Coefficient of 2.
Take a 2 out. And if I take a 2 out, I have x squared minus 1. X plus 1, x minus 1. Which means I'm going to have a hole in my picture. And that hole will be at -1, comma, 5 over -4. Now, we're not, your job isn't to graph this thing, but I am just to kind of help myself a little bit. What else do I know about my picture here? Vertical asymptote at x equals 1. A 0 at -6. A horizontal asymptote at 1/2. And I haven't done a y-intercept, I can. My y-intercept would be -3. But can you visualize this thing, guys?
Yeah.
So now, if you can visualize that, it doesn't have to be a perfect picture. If you can visualize it, then you can probably answer these limit questions. As we approach -1, oops, here's -1. As we approach -1 from the left, what's my limit? No, it's not negative infinity. As I'm coming closer to -1, I'm getting closer to -5/4. Remember, when it says x approaches -1, the limit value is y. So which y is this getting closer to? -5/4. And folks, does it matter which direction I come at it from? No. The limit toward to -1 is going to be -5/4, no matter what, because you have a point there. All right, what about as x approaches infinity? 1/2 from the top. The next one, as x approaches, oh wait, I think I did C first. I had to handwrite these on here, so. Okay, stop. I yelled at someone and I was doing the wrong problem. As x approaches 1 from the right, it's positive infinity, so I apologize to those of you I screwed that. As x approaches 1, from the left would be negative infinity. As I approach 1 from the left, it's negative infinity. As I approach 1 from the right, it's positive infinity. As I approach -1 from either side, it's -5/4. As I approach infinity or negative infinity, it's 1/2. On this side from the top and on this side from the bottom. So, let me get I had to handwrite this on here. So the answer to A is negative infinity. The answer to B is 1/2 from the top. The answer to C is -5/4. And the answer to D is 1/2 from the bottom. Sorry about that. Get my numbers straight. Okay? All right, did you find your end behavior asymptote yet? How do I do that?
I said we do, some synthetic division.
Absolutely, we can. So we'll put a 3 out here. 2 -7, 1. Yeah, I copied that one right? I had to handwrite all these on. So 6 -1. Right here's your asymptote. What is it? Y equals 2x minus 1. Easy, easy, easy. All right, now we're finding the average rate of change. We're not gonna do all of these. We'll do, you wanna do A, B, or C? A. Find the average rate of change, and our interval is -2 to -1. So that will be f of -1 minus f of -2 all over -1 minus -2. That's how you find average rate of change. It's like slope. It's like slope. So you take your second y minus your first y. Remember, f of x is y. Over your second x minus your first x. So with this particular equation or function, what is f of -1? Be really careful, there's a lot of sign action going on there. So -1 cubed is -1, but it's negative that, so that's gonna be 1. Minus 3, -2. And then plug in -2. What's that one gonna be? Same thing. This is -8, but it's negative, so 8 minus 6, is that 2? Over 1. So your average rate of change is -4. And you want to make sure that if it's a word problem, that you're putting a unit on that. Like feet per minute, or dollars per hour, or whatever the word problem is, make sure you're putting a unit on it. All right, number 12. We've already done one like this. I'm not sure why I put another one in there. Oh, this is one from some review work, linear or quadratic. So let's just look at B. Let's look at B. Guys, look at your x's. That's a little bit problematic. So, from the first point to the second point, what is the rate of change? I'm looking at table B. So from 1, 0 to 2, 1, the rate of change is 1/1. Would you agree with that? Now, from 2, 1 to 5, 4, the rate of change is 3/3. And from 5, 4 to 10, 9, it's 5/5. Linear, quadratic, or what? Linear, because the rate of change is the same. Don't forget to pay attention to your x's. All right, how do we solve number 13? It's a little inequality. How do we solve it? What do we need to do? factor by grouping. That is the most sophisticated that the factoring gets in this course. That's very simple. You've done it since you were in 9th grade. Factoring by grouping, we'll take out a 2x squared. And we'll be left with x minus 5. Take out a negative 8. X minus 5. Life is so good. X minus 5. 2x squared minus 8. What about 2x squared minus 8?
You can pull out a 2 and a
Pull out a 2. I'm gonna write that 2 at the front so it doesn't confuse me. And then I have x squared minus 4,
and it's a perfect square.
which is x plus 2, x minus 2.
Sort of the core.
Now I use a little sign chart idea. So here's my number line. I'm gonna have a dot here at 5, have a dot at 2, and a dot at negative 2. And then what am I going to do? I'm gonna determine whether the factors, these guys right here, are positive or negative in each of these regions. So, for example, if I pick 3, the number 3, this space right here, I would get negative times positive times positive. When I multiply negative times positive, I do not get positive, I get negative, don't I? So that area is not part of my answer. Then I do the same thing with this one. I try maybe 6, and I do exactly the same thing. And whichever sections come out positive, when you multiply it all together, those are your answer. Which you write in interval notation with parentheses and brackets. Okay, determine the degree of a polynomial. So these are polynomials, not exponential and all that. These are polynomials. Determine their degree. Okay, so let's quickly look at our x's. It looks like our x's are all good. Equal with intervals. So, looks like for my first one, my difference is -1. And then it goes to 2. And then it goes to 5. And then it goes to 8. What do you think when you see that set of numbers? Quadratic. Because look here, that's going to be 3, this is going to be 3, this is going to be 3. That's called the second difference. These are the first differences. They're linear, by the way, aren't they, going up by 3? So that's one way you can tell. Another way is to look at the second differences. If the second differences match, it's quadratic. If the first differences match, it's linear. Let's look at the next one. X's look good. Going up by 2, 10, 17, 23.
Yeah.
All right. That's okay. So this is 8, 7, 6, -1. So first differences, second differences, third differences. So what's the degree of that polynomial? 3. The third differences match.
You said the second one is quadratic,
This,
as in like,
problem A was quadratic because the second differences match. The difference that matches is the degree of the polynomial. Okay, concave up or down? Here we go, quickly, let's get A done. Concave up or down? Your x's look fine. What are your differences there? -3, -2, -1. So what's happening to those numbers? They're increasing. And if if the rate of change is increasing, then you are concave up. What if these were all the same? Then it would be linear and there would be no concavity, right? Okay, quickly, number 16. Based on this model, which is they give you an equation, what time does the number of cars in the parking lot change from increasing to decreasing? We're gonna graph this on our calculators, and what are we gonna be looking for if we're going from increasing to decreasing? Oh, no. We're going from, the curve is going from increasing to decreasing. We're looking for maximum. Yeah, we're looking for maximum there. And then finally, number 17, let's do A. On each interval, determine if the rate of change is increasing or decreasing. So from 3 to 4, those are X values. From 3 to 4, does our thing appear to have a rate of change that's increasing or decreasing? Increasing because the curve is concave up. Okay? All right. Next time I see you, we'll have a little quickie do over this kind of stuff. Yeah, whenever I see you. Right, good luck to any football cheerleaders, anybody else, we got stuff going on.